So this is the physical science lesson video for section 8.2, and so we're going to continue talking about solutions. So this is solubility and concentration. The maximum amount of solute that dissolve in a given amount of solvent at a constant temperature is called solubility. So solubility means how much can I dissolve in this given amount of solvent. Solubility is usually expressed in grams of solute per 100 grams of solvent at a specified temperature. So this is an example of a solubility chart. You have your temperature across the bottom and your solubility, how many grams of salt in 100 grams of water. Now when we say salt, we don't just mean NaCl. A salt is a category of compounds in chemistry. And so a salt is made from a neutralization reaction of an acid and a base. You don't need to know about that yet. So for example, like here we have NaNO3. So at 0 degrees Celsius, I can dissolve about 73 grams in 100 grams of water. But as I heat it, notice it increases. So if I heat it to 10 degrees Celsius, I can dissolve 80 grams. If I go to 20 degrees Celsius, I can dissolve about 88 grams. So solubility changes with temperature. Now what I want you to notice is most of these lines, they increase as temperature increases. Because remember how we talked about it's about collisions, and when things are heated, not only are they moving faster, the particles want to spread out a little bit. So that allows more room for more solute to be dissolved. Now not everything, like if you notice this one down here, not every single solid increases its solubility with temperature, but the majority of them do. So solutions can be described as saturated, unsaturated, or supersaturated depending on the amount of solute in solution. So let's talk about what those mean. So let's start with saturated. A saturated solution is one that contains as much solute as the solvent can hold at a given temperature. So for saturated solution, it has the maximum amount of solute possible. So if you add more, so that's what this is, saturated, if we add more, it will not dissolve. Alright, so if you add more solute to a saturated solution, it will not dissolve. So what would happen is you would have some left at the bottom. If you've ever tried to add sugar to tea, you add some, stir it, it dissolves. You add some more, stir it, it dissolves. It's still not sweet enough. You add more, but eventually it just settles at the bottom. And you stir, 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 and it'll kind of float up for a little while, but eventually it settles to the bottom. It is now saturated. It cannot hold anymore at that temperature. The only way to increase how much it can dissolve at that point is to heat it up. That's why it's best to add sugar to hot tea. So unsaturated solution, a solution that has less than the maximum amount of solute that can be dissolved, is called unsaturated. So unsaturated has less than the maximum amount. So if this is unsaturated and I add more solute, it will dissolve until it becomes saturated. Okay, so here unsaturated, add more solute, it dissolves. And again, that will keep happening until it's saturated, and then that extra solute will just settle at the bottom. Alright, last one is a supersaturated solution. So unsaturated is less than the maximum. Saturated is the maximum. So what would supersaturated be? Supersaturated is more than the maximum. So a supersaturated solution is one that contains more solute than it can normally hold at a given temperature. So because this has more than is even allowed, they are very unstable. Okay, they're very, very unstable. So if this is supersaturated and you add more solute, look what happens. The solute crystal actually gets bigger. So for example, this is kind of what it ends up looking like. Imagine if this was all a clear liquid and I drop a grain, let's say this is sodium acetate. I drop a grain of sodium acetate in there. Well, it's already holding more than it can. So what happens is extra sodium acetate will come out in the solid form because it's holding too much. Okay, so it's not just that it doesn't dissolve, it pulls extra solid out with it. So, what affects solubility? Well, there are three factors that affect the solubility of a solute, and they are polarity of the solvent, temperature, and pressure. Okay, polarity of the solvent, temperature, and pressure. So temperature, in general, the solubility of solids increases as the solvent temperature increases. And so I showed you that on that solubility chart in the previous slide. And that's for solids. So normally we can dissolve more solid if we increase the temperature. However, the solubility of gases usually decreases as the temperature of the solvent increases. So think about this. If I'm trying to dissolve a gas in a liquid, is that going to work very well? That gas is just going to want to bubble out. Okay, so what we have to do is try to make the gas more like the liquid. Well, how are gases and liquids different? Well, the gas particles are moving a lot faster. So if I can cool everything down, that kind of slows those gas particles down and it's more likely to stay dissolved. So for solid solutes, we want high temperatures. For solutes that are gases, we want low temperatures to increase solubility. So pressure. Pressure doesn't really affect the solubility of solids, but it will for gases. Remember, gases want to bubble right out. They don't want to stay in the liquid. So we're going to cool it down to get it to slow down a little bit, and then we're going to force it in with some pressure. So increasing the pressure of a gas increases its solubility in a liquid. So if we have a gas above a liquid and we press the gas down, it doesn't have as much room, so some of the gas will dissolve. That's why when you buy like a Coke or something and you open it, you hear that psh, because that's the release of the pressure. That carbonation is a gas that has been dissolved in the liquid. It's carbon dioxide. And so we want to keep the carbon dioxide in there. You don't want to open a Coke and it be flat. So concentration. The concentration of a solution is the amount of solute dissolved in a specified, that should say amount of solution. Wow, that was a terrible typo. Just pretend like that says amount. I don't feel like changing it right now. Okay, so it tells us the amount of solute in a given amount of solvent or solution in this case. So let's knock out this section assessment. So what terms are used to describe solutions with different amounts of solute? You can say unsaturated, saturated, and supersaturated. Unsaturated, saturated, and supersaturated. All right, number 2, list 3 factors that affect solubility. Well, you have temperature, pressure, and polarity of the solvent. Now, you may have noticed I skipped explaining that. That goes a little beyond the scope of this class. You'll learn more about polarity if you take chemistry. But temperature, pressure, and polarity of the solvent. Number 3, what are 3 ways to measure the concentration of a solution? All right, well, this question, technically we didn't cover it in this. I don't really know why I put this question on there. But you could say molarity, molality, and percent solutions, but we can just kind of skip that one. They must have covered it in the book, but we don't cover it in class because I pull these questions out of the book. So number 4, what is the effect of pressure on the solubility of a gas? Well, if you increase pressure, you increase the solubility of a gas. If you increase pressure, you increase solubility of a gas. So hopefully you understand a little bit more about solubility and the difference in unsaturated, saturated, and supersaturated, and the factors that affect solubility.